Hello and welcome to day 2 of the second week of the CAS Virtual Showcase. You have joined the second webinar of the day, entitled Creative Computing with P5.js. This webinar is part of the CAS Virtual Showcase, which is a 2-week window of webinars designed to support the CAS community. I'm Wendy McLeod and I'm the CAS Community Outreach Manager for communities across London and the East of England. Joining me this morning is the presenter of our session, Tina Getchie. Tina studied computer science in South Africa, where she worked as a developer before moving into education. She has taught computer studies, computing, IT, maths and art, and also has a foundation diploma in textiles. She joined Ada as head of computer science to lead the team in developing the curriculum and teaching the new BTEC in computer science, and she is now the vice principal. She is keen on the intersection of technology and creativity and enjoys sharing her enthusiasm with others. During the session, please use the question window on the right-hand side of your screen to ask questions. All attendees are in listen-only mode. The top of the window has an orange rectangle which can be expanded or collapsed. If using social media, the hashtag for the event is hashtag CASVirtual20. I'm now going to hand over to Tina for the session.
Thanks, Wendy. Hi, everyone. Oops, okay, it's just really confused me because it's gone to my face instead of my screen. I'm sure you hear this in a lot of these sessions. I'm not too sure how this particular GoToMeeting platform works. I think I've downloaded more meeting apps and things in the last couple of months than I have in my entire lifetime beforehand. So I'm going to see if I can find, oh, this is brilliant. I can find my slides. So as Wendy said, I'm vice principal at Ada, which is the National College for Digital Skills. We're based in Tottenham Hale, and all of our students study computer science. They study the BTEC computing, either diploma, which is a double A level, or extended diploma, which is a triple A level. We've had a huge amount of success with using P5.js as a teaching tool on some of the units that we teach. So I'm going to take you through some sort of beginnings of P5.js. So those of you who really have worked with it before, this might be a little bit beginner for you. And as you've probably got some communications, it would be helpful if you had pencil and paper, ideally grid paper. But if you don't worry, you can keep going anyway. So at Ada, our approach to teaching and learning programming, because all of our students are studying programming, is a bit like this. Just change stuff and see what happens. We really try to encourage our students to be comfortable with making mistakes, with learning how to deal with mistakes and that sort of thing. And this whole session is going to follow that sort of idea. More formally, we do a lot of pair programming, and we set up some very sort of strict ways of working where one student is the driver, another is the navigator, and we swap those roles regularly. We also follow, although not very formally, the PRIM approach, which I'm sure a lot of you are familiar with. And there's a bit of reading there if you don't know what these things are. If you want to read further, the NCC has a really good quick read on pair programming, and I think the PRIM structured approach is from either a Raspberry Pi blog or a King's blog. So P5.js is a JavaScript library. It's sort of mainly for, I suppose, creative coding, but all coding is creative. So, that's any kind of coding really that you want to be teaching. It's part of the processing community. So those of you who are familiar with processing might be, you'll see the familiarity there. We love it because it's free and open source and accessible. It gives students a different into coding. So often we start coding in a very mathematical way, and we do that at the same time. So we teach our Year 12 students both P5JS in one of the units and Python in one of the others. So we're teaching those in parallel. And we find, you know, the Python, we tend to do much more sort of mathematical things. And then with this, it's very creative. So it catches both sides. We really believe that technology and coding in particular is an engine for social mobility. That's one of our sort of founding tenets at Ada. And we really are very keen on the democracy of the web and keeping it as a democratic platform. So we're big supporters of Mozilla and what they do. And we regularly attend MozFest with our students every year. So what does P5JS look like, or what does the platform look like? So it's one of these free integrated development environments that are hosted online, and it has all the features that you would expect. There's a file manager, you've got the code editor on the left, and that does syntax highlighting. You've got the console there for error messages. And then you've also got a preview screen. The one thing that it doesn't do is host things live, so you can't then share a URL to share that work. You do have to download it and then host it somewhere else. So this is what the sort of skeleton of a P5JS bit of code will look like. Two important functions: setup. It runs once at the beginning, so that's everything that you want to do to set up the sketch, and then the draw function, which runs by default 60 times per second. That's the frame rate, but it can be changed. So we also have a really great reference, so you can go and see how to very easily change the frame rate, and it's simply a function call to the frame rate function with a parameter where your argument will be the number of times per second. And otherwise, the reference is also online and quite easy to find answers to any questions you would have. Okay, so this is supposed to be a workshop, so let's do some work. So the first thing, if you haven't already got an account on the site, go to that site and create an account, and let's start our first sketch. By the first sketch, I really just mean this. So it will automatically set up those two functions for you and draw this gray canvas of size 400 by 400. Okay, so I'll let you all get on with that. So you should go to the P5JS page and then follow the editor link. Create your user, and then when you're in there, if you hit the run, you should see the canvas, the 400 by 400 canvas with that gray background. So I'll give you a few minutes to do that. And if you have any issues, just pop them into the questions. Yeah, I find our students all have Ada logins, which are actually just Google accounts, so we use that single sign-on quite a lot. Okay, if you are there, why don't you start changing some things to see what happens? So at this point, you probably just have numbers to change, but you can have see a little bit of that. Steph asked, do we teach object-oriented programming? Yes, you do have to get into object-oriented programming once we do our more complicated stuff, because it is object-oriented. So we kind of teach it without explicitly teaching it. We sort of teach them to use it first. We actually go back and teach object-oriented programming in a more theoretical way later in the course. And then we can refer back to what they did in P5. Well, actually in P5 Play, which is another library built on top of this. So we only have Key Stage 5. We're at FE College, but I would start this with Key Stage 3, even Key Stage 2 if you had some very students who could handle the typing that would be required, because you can just do a lot of the if you think about Prim, you could do a lot of the just changing values and seeing what would happen. But I would do this from Key Stage 3 easily, and I'm going to talk a little bit about some like sort of teaching tips for this as well. Okay, I'm going to assume, unless someone says otherwise, that you're all okay and that you're there, and that we can move on. Okay, so we should all have that first sketch. So a little bit more about drawing. This might actually give you a little bit of insight about which key stage to start with. Think about in maths where students start sketching onto the Cartesian plane. Now, I taught maths for many years, and I'm actually not sure if I would assume it's in year 7, but someone can correct me if I'm wrong. Okay, so now this is where there could be some misconceptions, and you need to be ready for them, and you need to clearly signpost them. In P5JS, the origin is on the top left-hand side of the screen, whereas, of course, in maths, they would learn something very different. So I would suggest always being very clear. We're in P5JS, the origin is here. How would you do this in maths? So keep signposting that. All the numbers that we're talking about in the arguments are pixels, so either the size or the position. And you will always need to have a canvas on which to draw. If you leave off the canvas, create canvas, you will get a canvas, but it'll be the default tiny size. So just think about that. Okay, shapes. There's quite a lot of functions to draw basic shapes, so rectangles or squares. 4 arguments you'll need to give to the rect function, and that is the starting x and y coordinates, and then the height and the width. So you could try drawing a few rectangles. Now, obviously, the size of your canvas will determine the size of the rectangle that you can see. It will not give you any error messages if you go over the size of the canvas. It'll just draw a rectangle that goes over the edge. So just using rectangles, try to plan a drawing and then code it line by line. So this time, if you do have grid paper, this will be really useful because it is a lot easier to lay it out. So if you don't, you can use my example, which you can see in front of you, and I think you have a copy of these slides as well. And it really is a good idea to code it line by line. So you'll notice on my piece of paper, I've made a mistake with practically the first four rectangles that I drew. They all had a mistake, and I only noticed them once I had coded it. And then it's also very easy to debug because you have the visual of what's happening on your screen. So take some time to write some code that will give you a little drawing based only on rectangles. And so that I can see how you're getting on, and so we can see each other's, get a little bit of interaction here. I've put a Jamboard together. So that's the one that's the output of my drawing over there. You could just take a screenshot of it and plonk it into that Jamboard. But before I go on, the great thing about doing an exercise like this is that it gives you many opportunities for all sorts of great teaching practices, like paired work. You could get students to dry run each other's code before they actually code it in and see what would happen. You can peer mark, so you can get students to look at each other's and find each other's errors. And also it gives you many opportunities for differentiation, whether that be within a class or across key stages. So for example, you could just give a student the drawing already sketched up like this and ask them to give you the coordinates. You know, you might not want to start with a class where you're just giving them a blank page. They might find that overwhelming. So it really gives you a lot of opportunities for differentiation. Okay, so I'm going to jump across to the Jamboard, and I can see we've already got some anonymous hamsters and other strange cheetahs and turtles. When you've got something, and don't worry, we are not we're not looking for a beautiful art. You'll notice this is actually a later screenshot where I've added a few circles as well. So I'm going to give you a bit of time to make your own drawing and get a little bit more familiar with P5.js. And I'll just keep an eye on questions if there are any.
Tina, there's a couple of questions that have come up. One was about the link for the Jamboard, Dominic's asked.
Oh, sorry. So it's bit.ly/CAS in capitals Jamboard. I'm just displaying it on the screen now, and I see we've actually got. Sorry, Wendy. For some reason, I can't see that question. Is that coming to you?
Yes, a couple of people have just asked the same question actually. Yeah, I can send that out to.
Yeah,
everyone.
that would be helpful.
They've got it. And so
got
Taslim said, I tried to PA's parameters to function draw, but it generated error.
Sorry, try to no. You'll never pass any arguments into the draw function. The draw function is something that the runtime environment will call 60 times a second. So if you have a look at my code over here, those are two things you're never going to mess with. Function setup doesn't have any parameter list there, either does function draw. So we're inside the draw function, so inside the curly brackets of the draw, and we're simply adding rectangles, rectangles, rectangles. You'll notice I've got some comments, some very unhelpful comments unless you see my numbering over there. The comments refer to the number of the shape. Any other questions?
You answered about the key stage. That was a question. So you said, just to reiterate that, yeah, from key stage 3. Steph asked, do you teach OOP with this?
Oh, right. Yeah, no, I did answer that as I saw that one coming in, and the answer was yes, but more with P5, sorry, with P5 Play, which I'll talk about a little bit later. Okay, we're getting some drawings. Oh, we've got what looks like a bunny and a smiley face. If there's no space on that particular Jamboard page, just go to the second page. I'll just let you create a little bit more. We've got someone who's used symmetry really well, to do more of an abstract drawing. I really like that. And someone who's just put in also a nice smiley, looks a bit like a minion, and used some ellipses there. So as you carry on playing with that, let me talk to you about a few more shapes, and you can add to your drawings if you'd like. So we've got ellipses. Now with ellipses, we've changed the paradigm where the beginning coordinate is actually not a corner but the center of the ellipse. You can change that, but by default it's the center, and then you've got again the height and the width. I find that slightly counterintuitive to change that paradigm so much as the default, and sometimes students really struggle with that, although it does make putting your ellipses in the correct position a little bit easier, because the corner of a circle is a little bit harder to determine. So that's how I put my face on my teddy. There are a lot more complicated shapes. Triangles, quite difficult to work with because you've actually got to determine the coordinates of the three corners. Arcs, which are even more difficult because you've got to have some sort of understanding of angles as radians. And if not, you're going to, I mean, this could really confuse, especially Key Stage 3, Key Stage 4 students, and anyone in Key Stage 5 who is not doing maths. So you could just teach them pi is 180, half pi is 90, and 2 pi is 360, but they're going to have to do a little bit of work understanding that. So if you have time, or if you'd like to try this later, triangles or arcs or ellipses. Here's one that I did a couple of years ago to create that particular bit of code that I've highlighted there is just to create that red heart between the two little people in the flowers. So let's see what we've got in the Jamboard. Oh, great. Podgy person there, I like it. And also I'm seeing some color as well, so that's great. Oh, we're already on page 3. Oh no, nothing on page 3. So seeing as we've already had some exploration of color, let me throw some color into the mix. So every shape, first of all, has got a fill and an outline. The outline is called the stroke. Oops. And the fill is, so the stroke is the outline color, and the value will, if you just give one value, so if you just pass in one parameter, it will be something on a scale of black to white, so a gray scale. Similarly with the fill. So you can have a value from 0 to 255, and you'll get something in grayscale. If you want RGB color, and also if you want transparency, you've got the option of giving 3 values, again between 0 and 255, and an alpha value, which is a percentage of transparency. So a great time to be working with RGB values. If you'd rather not have an outline, you can use the no stroke function. And just another thing there, the value of the value, which I'm sure you already had worked out. So classic RGB. Obviously, besides red, green, blue, and possibly cyan, magenta, and yellow, white and black, I don't know any RGB values off by heart. I tend to use a color picker tool. And students, of course, can go down a massive rabbit hole picking colors there. But it does allow for a great link to the image representation part in the theory of both GCSE and A-level and BTEC computing. So it would be great for as an activity while you're teaching image representation with your students to do a little P5JS color programming, to really give them an idea of how color is made up and how it's represented inside the computer. So if you'd like to... Sorry?
Tina, sorry, just a question about colours. Dominic asks, can you use hex rather than 0 to 255?
Not in P5 as far as I know. If you have a look at the reference, you can see whether that's, let's have a quick look. So if we look at the reference and we look for fill. So fill is a bit misnamed for me because for me, fill is now fill this item, but actually in P5, fill is pick up this color pen. So as you can see, yes, you can, there we go, 3-digit hexadecimal RGB. So you can use, if you know hex codes, there you go. You can either use them as 3 digits or 6 digits. So someone can try that. Just remember to put the hash. You can also use this hue saturation B. I'm not sure what the B is. Hue saturation brightness? Not sure. So maybe the graphic designers amongst us.
There's another general question. This one is from Laura. She asks, is there an ability to use something like Turtle to take a line for a walk around the screen?
Yes, once we get to dynamic drawing, although it's slightly different. It is a slightly different paradigm because you've got running at 60 frames per second. So you can see something animating, but it's not the same as turtle drawing. It is a slightly different idea. You don't have this static canvas that you then control the drawing onto. You have this, it is an animation tool. So at the moment, what's happening actually is your static drawings are being drawn 60 frames per second. You just can't see that happening because it's so quick that the human eye isn't picking up the frame rate. If you were to slow down the frame rate, you would see your drawing flashing on the screen. So in some ways, it does give a false, students and us as well build a false mental model that this is some kind of static thing. And you'll see as soon as we go into the dynamic drawing, the power of the animation of P5JS. So I wouldn't use it in the same, it's not a, oh, I've been using Turtle, I want to use this for what I do in Turtle. I don't think that's a good idea because it's quite a different thing. This is really for ideally animation, but it's possibly, especially with lower key stages, it's a bit mad, I think, to start with animation before you've understood the canvas and the layout and the colors and that sort of thing. I mean, you can get quite far with just a little bit. So really, you don't need much more than rect and ellipse and fill and stroke, maybe, to do quite a lot. But after that, you probably want to move to the animation. Okay. Can't seem to click on my Jamboard. Oh no, there we go. Oh great, I'm seeing some great use. Oh, people have got some rounded corners and have done some, I don't know if those are arcs or, oh, we seem to have lost a lot of work. I don't know if someone inadvertently deleted page 1. No worries, let's move on because I can see we're already half an hour in and there's more stuff to do. Okay, so we talked about all the color. Let me just jump over that one. Whoops, and you have added some color. So this is the kind of work we do with our students. This is their first bit of homework that is due. We ask them to do a drawing, exactly like what you've just done. So you can see the output that the students come up with. And the great thing about it is it really gives them a chance to, some of them, they're quite conceptual. So this one over here with the concentric circles, someone's really just sort of played around with the maths. They do quite love a bit of pixel art. So we've got Mario there. We start them with drawing houses and that sort of thing. So you can see a lot of them have stuck to the house theme. We've also used it in our taster sessions. So we ran some virtual taster sessions for our incoming students. And this is what we presented them with some P5JS tutorials in the morning. And then we came back in the afternoon, and this is what some of the students had created. So these are year 11s who will be our year 12s come September, just noodling around for the day. And it's quite impressive what they came up with. So let's have a look at some dynamic drawing, because this is really where the power and the features of P5 come in. So this immediately allows you to do a lot more teaching of programming concepts, like commenting is going to become really important, because otherwise you just don't know what's going on in the code. The use of functions and parameter passing also becomes really important. So I'll just show you this one as a dynamic drawing. So this is one of my colleagues created. I can't take too much credit for it. Sorry, this GoToWebinar thing is totally in my way. So my colleague Alex was inspired by our college building. Oh, doesn't want to run. There we go. And they created this. Quite sophisticated. The clouds I'll show you how to do. The bouncing buses required some quite sophisticated trigonometry, so we don't need to go there. But that's the kind of thing we can do. And what's happening there is the animation is happening by virtue of the fact that this draw function is being called 60 times a second. So actually, there's all that Alex had to do in the code was to change some values of coordinates. And I'll show you how to do that. Okay, my computer is going absolutely mad at the moment. Okay, so these were actually two of the drawings that our students on the taster session did. They actually had animated them as well. So this is year 11s with a couple of hours of work. This is what they could create. So pretty impressive. So it's a great tool like any other programming language to teach control structures. Sequence is super important because the order that you put your shapes on the screen will determine whether you can see them on top of each other or not. Selection, when you start animating, selection will be quite important, because if you want something to come off the edge of the screen and then appear again, you're going to need to do some selection. Is a little bit more difficult because the iteration in the draw function is happening by default. And if you actually do something like a for loop within the draw function, what's happening is you're getting a sort of nested iteration. So it can become a little bit confusing. So I've got a couple of examples there, and all of the code is laid out on the screen. So you can try one of these examples and then start changing things to make stuff happen. So when you start with animation, variables are going to be important, because that's one way you're going to change how the colors change or how the coordinates change. So I've stuck to the convention that RGB means colors and X and Y are coordinates of whatever shape we're talking about. So you'll notice here that I've set them all to initial values. And then in the draw function, I'm changing them by a step of 10. and you can see what occurs. It's just then drawing across the screen. Because I'm changing X and Y, we get that diagonal line. And because I'm changing the RGB values by 10 each, we're sticking to a grayscale over there. Now, I think you all have a copy of these slides, so you might want to, if you want to recreate that, you might want to look at those particular slides. The next one is an example of using a for loop within the draw loop. And what happens there is, instead of just drawing one square, it draws a sort of extruded square. So what happens with this one, I'll show you in a little bit, it sort of extrudes that square coming out. It looks quite cool. So that's quite a nice one to then give to students and get them to start changing things and getting some really interesting art happening. If you want to change color and change the palette and make that a little bit more mad, first of all, you've got to be changing the R, the G, and the B by different values, because if you're always changing it by the same value, you're staying on a grayscale. So the random function is quite a useful one here. It's not, you don't have to import any special libraries or anything. It's built into the sort of P5JS libraries anyway. So you'll see here that instead of changing colors by a particular amount, I've just set it to a new random value between 0 and 255. And then what happens is you'll get these random colors. And then finally, a kind of sort of combination of all of those things. I've first of all slowed the frame rate down a lot so that you can see these bubbles as they appear. I've taken the stroke off to give the appearance of bubbles, and I've also used some transparency, the alpha value between 50 and 100. So I've changed the transparency of each one. So, oh wait, and then my final one is these are clouds floating across the sky. So if you want to give that a go, I've got 3 clouds. That's x1, x2, x3. Those are my different starting coordinates for those clouds. And then as they go to the edge of the canvas, you can see in my selection, if their coordinate is greater than 400, which means they've reached the edge of the canvas, they wrap back around. It just gets set back to 0. So it's a bit like the scratch cat hitting the side of the screen, but wrapping around to the front. So you've got 5 examples there. You can use one of the examples as a starting point, or you can start your own, as you putting bits of those together, and you can create a dynamic drawing. Just going back to the questions, I can see Anita has asked something about a scheme of work, but I can't. Oh, do I have a scheme of work and lesson PowerPoints? I'll be talking about that a little bit later, because we teach Key Stage 5, we're teaching sixth form. We've got a very particular scheme of work that links into exactly what it is we have to teach. So it probably wouldn't be exactly relevant for another context. And I also think that you know your students better, you know the outcome you want from those students. I think it's probably necessary for a teacher to go through and create their own based on exercises they've done. I've got a few resources at the end to share with you, but nothing as like here's ready to go, nothing like that, I'm afraid. Could you create a game? I will talk about exactly how we create a game. We use another library called P5 Play, which does a lot of the game sort of, what's the word, like physics of the game. So that's what we eventually use it for. So why do we prefer P5.js over Java in processing? I don't think we particularly prefer one over the other. It's what we started using, and now we built up, I think we're using it for the second or third year, although we might change our minds, where we often like to challenge ourselves with new things. So we're kind of looking at maybe using a games engine. We've just really, that's what we've sort of kind of got onto working with. So now we have all of these resources and understanding, and we're quite happy with it. I don't think Java in processing is better or worse, but you know, if you're familiar with something and if you have resources based on something, you do tend to go on with that. I do know both Queen Mary University and Goldsmiths University's creative computing courses use P5.js or processing, which really, I mean, there really are much of a muchness. We quite like the interface, the online interface of the P5.js. The reference is really easy to use. Yeah. Okay, I'm going to leave you for maybe another 5 minutes to play around with.
Yeah, just to say, Tina, we've got 3 minutes left.
Oh, are we only 45 minutes? Sorry.
We are, yeah.
That's fine. Okay, well, then I'll zoom through the rest of it. Okay, so games using P5 Play. So P5 Play, if you Google that, you'll get a lot of really great help on the GitHub page, which looks a bit like that. And you'll notice as well, this has got fantastic little examples of how to do all sorts of different things that you would need in a game, right? Like controlling sprites, creating sprites, working on their appearance, how to make things bounce, how to overlap, collide. So for example, like collision is quite important in a game, that sort of thing. So we teach the diploma, the BTEC diploma, and we teach Unit 14, which is computer games development, and we use P5 Play to create, for the students to create a game. We also limit them with using emojis so they don't get too bogged down with creating all the graphics for the game. And this is an example of a game that one of our students has created. So eventually we move into using an online tool like REPL.it and doing everything in there because we want to host it live. So if you can follow this URL and find Julian's Robot Meets Alien, and you can see the kind of game that this takes our students about, I suppose, about 2 months to create. And this is an example of an exceptional student. So we've got a lot simpler things going on with our students, which is perfectly adequate for the game they have to create, because they also have to do all of the documentation, the design and the testing and the evaluation and all of that. So there's just a link to the resources, some of the stuff that I've mentioned throughout. There are some good learning activities online using P5. If people do want copies of the stuff that we use, feel free to email me, tina@ada.ac.uk. But I have to just say it's very in line with what it is we're teaching, and I would really recommend. I know it's a lot of time to create your own resources, but that way, I mean, you know what your students need, you know the outcome you're trying to get. And you know, in that way, you'll also be able to help them with their learning because you'll be immersed in it as well. So that then takes me to the end of the session. If there are any other questions.
Yeah, I think squeeze it very quickly. We've got one question. Do you use the online editor with students or do you download it?
So we start with using that online editor, but then once they become more familiar, we actually then get them to use something like Repl.it or something like that. because then they can just refer back to the, once they've loaded the P5JS library in their HTML, then they're really just writing, in the JavaScript page of their web app.
Thank you. And final question, are there any online tutorials available?
The P5JS page, everything you need is there. So there's reference, library, learn, examples. Really, you don't need to go any further than that. There we go, getting started, overview, how to do different things. It's all there, what you need.
Brilliant.
Although I'm sure YouTube has got a lot of stuff too.
Yeah, brilliant. Okay, well, thank you everyone who's joined us today. A special thanks to Tina for presenting. Please share your highlights from today's session via our social media and the CAS website. At the end of this webinar, a short survey will appear on the screen, and we'd be really grateful if you could take a minute to complete the survey. Additionally, in about a week's time, you'll receive an email with a CPD certificate confirming your attendance at this session. A recording of this webinar will be available on the CAS website in the near future. And as we've already mentioned, we will send out the slides for this presentation. I'll do that later this afternoon. Coming up this afternoon, we have sessions on tools and strategies for teaching programming at Key Stage 3, computing role models, a cyber first update, and starting your own code club. We hope to see you at other sessions, and please do continue to spread the word about the first ever CAS Virtual Showcase. Thank you so much for joining, and I hope to see you next time.